The method of least squares. The method of least squares says that the line of best fit is the one for whose the square of summation of error is the minimum one. Here you see the in this diagram you see the regression line. Uh, Here is on x-axis you see the x independent variable, while on y-axis you see dependent variable, and here the red spot shows the data point for each individual variable here, here, and the distance between the red point and the regression line, this we call error. And here this square shows the square of error for each individual data point. This is for one point, it's for another, and so on. So according to the method of least square, the line of best fit is the one for whose the square of summation of error is the minimum one. So the summation of square of error, this is square of one error, this is for another one, and here another one, and the summation of square of all error is the minimum one. So the line for which the summation of square of error is the minimum, that line will be the line of best fit. Here you see the sum of square of error for this regression line is 0.48. Uh, the basic objective of the method of least square is to find the line of best fit for a regression line. Here you see this is the regression model, linear regression model. Here this is y estimated, this b0 is intercept, and b1 this is the slope, and si is the independent variable. Here in this diagram here you see, so the dots here, this is the scatter plot, this is the dot for individual data point, and here the distance between this dot and the individual line, this we call residual, and here this green line, it shows the regression line, it is the line of best fit. What is the least square criteria? The least square criteria is the use of three formulas. The first one is the regression model. The y estimated is equal to b0, that is slope, plus b1's b0, that is intercept, plus b1, that is the slope, and x is the independent variable. Here slope we can calculate with the help of this formula. Intercept b0, that we can calculate with the help of this formula. And for example, we have a data set in which the x variable having the values 4, 5, 6, 7, 10. The y variable is having the value 3, 8, 20, 30, 12. And here this diagram shows the scatter plot. But here this one line, there is another and third line. We don't know which line is the line of best fit. So in order to find the line of best fit, so we need to take help from the method of least square. How we can find the line of best fit? So in order to find the line of best fit, we need to use those formulas. One was for the slope, that is here, slope is equal to b1, and here we have these terms. For intercept we have b0, and we have these terms. In order to calculate these terms, so we are taking help from this table. In this table here you see xi is the individual independent variable. The individual xi for x1 variable is 4, for x2 5, 6, 7, and 10, and for y 3, 8, 20, 30, and 12. And here xi minus x bar, this is the deviation. What is x bar? X bar is the average or mean. This is equal to the summation of all individual variable divided by the total number of observations. In this case it is 6.4. Similarly, y bar or y average is equal to the summation of all individual variable divided by the total number of observation. In this case it is 14.6. So here in order to find the deviation for individual x variable. So individual x variable is here. The value for the individual x1 is 4 minus 6.4. 6.4 is the mean value and is equal to minus 2.4. Similarly, for second x variable, the individual value is 5 minus 6.4 and is equal to minus 1.4. Similarly, for the third, fourth, and fifth. Now here this is the square of the deviation, xi minus x bar whole square, and here in this case we have to square the individual deviation. So for the deviation 1 is minus 2.4 and we are taking the square and it is equal to 5.76. For the second variable it is 1.96 and so on. Here the y variable, and here we are taking the deviation of individual y variable. For the first y variable, the individual value is 3 and 3 minus 14.6. 14.6 here you see this is the average for y variable, so is equal to minus 11.6. 8 minus 14.6 is equal to minus 6.6, and here we are getting we are calculating the deviation for each y variable. And here in this term here you can see this is the product of the deviation from the x and the deviation from the y, and here is the product of the deviation for the x1 and the deviation for the y1. So this is equal to 27.84. Similarly for the second variable, so 69.24 and so on. Here you see in this table you see this is the summation term for the xi. The sum of all the observation is equal to 32. For the deviation is 14. Here for the y there's 73, and here for the product of the deviation for the x and y is equal to 34.8. All these values we have to substitute in these two formulas. So to putting the values in those two formula, so here we are getting 34.8 divided by 14 is equal to 2.48. This is the estimated slope, that is b1. Intercept here, for intercept b0, y bar minus b1 into x bar. So b1 is 14.6 minus 2.48 into 6.4. 6.4 is the average for the x variable. So here the intercept we are getting 0.76. Now using the regression model, that is the y estimated is equal to intercept minus slope into xi. So here we need another table. In this table here you see this is the x variable, the x1, x2, x3 and x4. For x1 the value is 4, 5, 6, 7 and 10 here, and here you see this is the regression model formula. So for y1, in order to estimate the magnitude of y1, so is equal to 0.76 plus 2.48, and here we have to put the value of x variable, x1 variable. In this case we have to put the value of the x2 variable, and here we have to put the value of x3 variable, and here we have to put the value of x4 variable, that is 7, and here this is we have to put the x5 variable, that is 10. So by putting the values in this regression model formula, so we are getting the estimated value for the for all the y variable. For y1 it is 10.68, for y2 this is 13.16 and so on. Now in this table here you see this is x is the individual value 4, 5, 6, 7 for the x variable, yi this is the values for 3, 8, 6, and this is also the dependent variable, this is independent variable, and here you see this is the estimated y. So the estimated value we have added a third column that containing the values for the estimated value, and now we have to plot it. After to plot it we are getting the scatter plot like this. Here you see this is the individual line, and here you see the green line, it shows the line of best fit that we obtained. We got it with the help of the method of least square Okay, and what was the method of least square? The method of least square was saying that the line of best fit will be the one for which the summation of the square of the all error term is the minimum. So here you see, in this case, here you see the all square value. Here we are getting 1, that is the maximum one. But for this one, for this line here, you see the R square value is 0.126. So it shows no correlationship and the thing like that. So here you see this is the application of the method of least square, and with the help of method of least square we can find the line of best fit, that line which having uh, minimum the summation of the error, minimum the summation of all the errors. Thank you.